Hello viewers, the last concept of electricity chapter is heating effect of electric current. So what is this heating effect of electric current? Means let us imagine you suppose your mixers or grinders, anything, after working some time, okay, after they are working some time, you come to touch them, you will feel the hardness. That means if they are converting electric energy to the magnetic effect, that means rotating of motor, after if it is converting one form is magnetic effect and also it is converting the heating effect also. Not only that, suppose you will see the light, okay, after working the light, after suppose 10 minutes of light is coming, after that you switch off and just touch the bulb, you will feel the hardness. That means it is coming light energy at the same time it is producing heat energy also. That means that is effect what we call heating effect of electric current. When we pass electric current through any electrical appliances, what will happen, they will produces the heating effect, okay, that effect what we call heating effect of electric current. Or else, to understand this better, do some small activity. Let us take one thermocol sheet and take one two pins, okay, which will have two rods like iron knives we're going to take, and connect one small wire, okay, very thin wire you're going to connect between them, and connect this to some kind of battery, okay, to pass the electric current. When you pass electric current, after 10 minutes you're going to observe and okay, switch off, and again you just touch the wire, you will feel the heat. That means this wire is getting hot. Why wire will go to hot? Because of its resistance. If wire having a more resistance, becomes more hot and hot. If wire is very thin, sometimes it will going to melt also. So okay, this is what we call heating effect of electric current. In this, we're going to explain heating effect of electric current as explained by the Joule. Okay, that is why we call Joule's law of heating. Okay, how it is related to electric current supply. Suppose you heat more time in touch, will feel more heat. That means it depends upon the time, amount of heat liberated, depends upon time factor, depends upon how much resistance of the circuit, how much potential we apply, how much power is going on. That means how much current is flowing in the circuit. All these factors it will depend. Okay, let us learn Joule's law of heating effect and what factors it will be depending on. Yeah. Here, thermoelectric effect. Thermo means heat, electric because of current. Thermal energy is produced. That is what we call thermoelectric effect. When current flows through a resistor, okay, when you pass current to resistor means any wire or bulb also containing tungsten filament. Like that, when it passes through resistor of some electrical energy delivered to the resistor is converted into the heat energy and it is dissipated. Okay, this heat effect of current is known as a Joule's law of heating. Clear children, when you pass electric current through any electrical appliances, what will happen? How much of amount of delivered current you apply, no? In that sum is converted into the heating energy. That is what, and it is dissipated. That means it just go outward. How much heat loss, what we call heat going to loss. That dissipated will be derived using the Joule's law of heating. Okay, just as current produces thermal energy may also be suitably used to produce electromotive forces. This is what we know as thermoelectric effect. Okay, using that heat energy will produce electromotive forces. Okay, yeah. Okay, more clearly, if you want to see the Joule's law, how it is means if current I flowing through a conductor, suppose we connected conductor in a circuit, in that how much current is flowing through a conductor kept across a potential difference V for a time t. The work done or the electrical potential energy spent is, so work done is nothing but potential into current into time. So VIT is nothing but potential current under time T. Okay, how much work done is equals to VIT. The absence of any external effect, this is energy spent, whatever energy spent to heating this, that to do this work, that will be equal to heating of the conductor is the amount of heat produced is equals to H is equals to VIT we are going to take. And we also write this as a H is equals to I square R into T. Okay, we can derive this from this. How it is, children? V is equals to what? It is I into R. Okay, V is equals to IR from the Ohm's law. Okay, just apply this rule here. In place of V, I am going to replace with the IR. So replace H is equals to V plus I into R into I into T is this. So this I into I becomes what? I square R into T. So that means in Joule's law of heating is directly proportional to this factors now. Yeah. For resistance, okay, for a resistance, what we going to write? Joule's law is H is equals to VIT or I square RT we can deduce. So from this, so how we can write the relation? This relation experimentally verified by the Joule. That is why this is known as a Joule's law of heating. It is stated that heat developed in an electrical circuit due to the flow of current varies directly as. That means heat developed in an electrical circuit is H. Okay, that is a heat developed in an electrical circuit due to flow of current. Okay, varies directly. How it is varies in square of the current. Okay, I square. Oh, this is a heat. H is directly proportional to the square of the current dissipated. That is a flowing in the circuit, and it is directly proportional to the resistance of the circuit, and it is directly proportional to the time, how much time it is flow. If more time the electrical appliances is working, then more heat will liberate, right children? Okay, if less time it is working, means less heat it will be. So if resistance is high, that time the heat generated will be high. That is why you're going to use a good conductors. If you use a bad conductors, that time what will happen? The heat energy liberated is very high. Or else you just observe the old geysers and the new geysers. The old geysers will utilize more amount of time, okay, to boil the water instead of a new one will fastly while because of again resistance will be high. Okay, that is the reason. And square of the current. Or if current flowing is more, that time heat liberated will be also more. If less current is flowing, less heat liberated. Okay, children. So now you clear with the Joule's law of heating. That is how much of heat lost or heat is equals to I square RT. This will have advantages also. Okay, let us see what advantages it will have. Applications of Joule's heating or heating effect of electric current is one is electric iron, electric heaters, electric toaster. In all this, what will happen when we passing electric current, we are getting what? A heating effect. Because of heat, we are electric iron works or heater works and toaster works. Okay, all this appliances utilize the heating effect of electric current. In these appliances, heating element are made of nichrome, the alloy of nickel and the chromium. Okay, it has special property having a very high resistance. Okay, with a property that they have high resistance. What will happen? You know, H is directly proportional to R, right? The heat produced will be depends upon resistance. If there is a high resistance, that time it will be approximately 10 power of 6 in the joules. And nichrome has a high specific resistance. That is resistivity means rho. High specific resistance and can be heated at very high temperatures without any oxidation. That means without any reaction, it will be heated to up to very high temperature. Clear, children? This is what all the electrical appliances will be work on it. Want to see the picture of electric iron heaters and the toasters? All will be heating element will be present in that. That will be working actually. Okay, example you want to solve, just try it. And electric fuses also, there is also working principle of heating effect of electric current. When more heat will come to the nichrome wire, you can see the fuse picture here. Yeah, this is actually. You can observe the fuse actually. It will have the base is insulating, and here in the inside fuse box, what we can call. You can observe here the small wire. No, if a high current will come, the small wire going to melt. Okay, this wire going to melt, and inside your appliances will be safe. This fuse will act like a gateman or watchman to your house. If any extra persons will come, it will going to stop, right? Like that. If current is, it will come more than 240 volt. Our electrical appliances inside our home, they will be tolerate up to 240 volt. It will come more than that power. This wire will going to melt. Okay, the fuse box inside this wire going to melt, and this will be instruments will be safe.